Welcome, everybody, to the BCA's Tech Talk. We're glad you all could make it today. We're excited to start off the new year with Brian Graham presenting the Honeywell Jade Economizer Controller. Just a couple quick reminders for everyone. This is a member-only benefit, and we are excited to be able to bring it to you. So just a quick reminder, if you have not paid your renewal, please do so you can continue to enjoy these great Tech Talks. We do record them. They are up on the website. The passcode for members to get in to see them is TechTalks 2017, at least for right now. It's all one word. You can go find them on the resource pages of our website and see any of them that you might have missed. And we encourage you to do so. We've had some really good ones. And also a reminder that this year for the BCA is our 20th anniversary. We will be celebrating the birthday of the BCA in October. Its actual birthday, I believe, is October 18th, but we're going to celebrate at the annual conference in Nashville, Tennessee this year, October 15th through the 18th at our conference. So we hope you will join us for that. It's going to be a great conference, a great learning event, but also a really fun birthday party for the BCA. So with that, I want to turn this over to Brian Graham, who is a commissioning provider and energy engineer for Design West Engineering. He has over a decade of commissioning, facility management, and energy engineering experience. At Design West, he provides commissioning for Title 24, for the LEED program, energy performance analysis, retro commissioning, energy master planning, design review, O&M training, quality control, EMS controls. I could go on, right? Brian has a great deal of experience working with complex mechanical systems, commercial and corporate office buildings, municipal buildings, and education buildings from K-12 to higher ed. He holds a Bachelor of Science in Mechanical Engineering from the University of California, Riverside, and a Master's of Science in Systems Engineering from the Colorado School of Mines. He's a licensed professional engineer, a certified building commissioning provider, and a lead AP. He's also the secretary for the California Chapter Board of Directors for the BCA. And with that, I'm turning it over to Brian and let him take off with it. Thanks, Brian.
Thank you, Liz. All right, everyone. So today we're going to be talking about the Honeywell Jade Economizer Controller. If you want to read the description, hopefully you already had the chance to do so. In regards to the agenda, we're going to go over a brief overview of just what I call next generation economizers for small rooftops. There's been a lot of improvements over the years, so we're going to touch on that. Then we're going to go over the smart economizer controllers that are in the market for these small rooftops, design phase tasks that are related to the economizers and the controllers that control them, and then really get into the specifics of the Honeywell Jade controller. And then we'll wrap it up with lessons learned from my experience in the field. So long gone are the sort of frustrating linkages, leaky dampers, all the frustrations that ourselves as well as facility managers had in regards to the economizers. So the first big improvement are these gear-driven dampers, and you can see in the picture on the right, there is a black circle inside that cabinet. There's two of them that you can see. Those are gear-driven dampers, and so what that does, instead of having the linkages that would eventually fail, these are toothed together, and it just allows for a much better, smoother actuator and a lot longer life. In terms of sealed damper blades, the units, at least in California, and I'm sure that it will make its way across the country if it hasn't already, are ultra low leakage. So the total leakage is less than 1 inch across 10 CFM with 1 inch of pressure, and that's just compared to the dampers of years past. That's a huge improvement. One of the requirements for these units is 60,000 actuations or cycles for the actuator. So these actuators are going to last a really long time. And then what we all came to talk about today are the smart controllers, and so that's the next improvement for these economizers. What you'll see here are two products. The two products that I'm most familiar with on the market. The Jade is on the right, and then there's a product by Belimo called the Zip Economizer. It is very similar to the Jade. I think the only improvement I'm really aware of that sort of sets it apart from the Jade is that, at least in California, if you put in the zip code, if the contractor types in the zip code, it actually sets up the code required economizer set points. So it's kind of a nice feature. It helps remove the sort of gets rid of all the issues that might come from contractors not knowing how to program the controller. I would say that the Jade, at least in my market, has a lot more presence. So what's important to all of us, design review. Early on, I've seen some issues come about that really could have been headed off if we had gotten to them earlier. So the first one is just power. The picture at the right, you'll see, at least you'll notice one disconnect. And when I looked at this unit, I saw a disconnect below, and then I saw what I thought was a outdoor, the cover to an outdoor service receptacle. So what you're actually seeing there is a disconnect for the powered exhaust, and then above it is the disconnect for the unit. That small, lighter gray, what looks like a service receptacle, that's actually the disconnect. And what I found is myself, as well as the facility team at this site, did not know that power was not completely isolated, that two separate circuits were feeding this unit. And so what we advised in construction, and unfortunately that led to a small change order, was getting signage on all these units to say, this unit is separately powered. And so just I would encourage early on to get in Division 26 to have signage for the rooftop units. Next sort of item that can be concerning is the cost of these economizers. Title 24 compliance, but also ASHRAE and IECC closely follow the same. I would say that probably Title 24 stole from those two specifications. So cost can be a really big issue. I've seen prices between $1,500 and $2,000 just for the economizer. And when you're talking about a 3-ton rooftop unit, that can be 50% or more of the cost. And so you really want to talk to the owner and really understand during the OPR development, does the owner want the economizer, understand the cost, and are the hours associated with this unit's use make sense to actually have the economizer installed? So that can be a good thing to bring up during your OPR discussion. Other things you want to look for during the design review are factory or field installed sensors. In regards to the Jade, you can go two routes. You can go a Honeywell proprietary sensor, so that's going to talk via their Silk Bus communication protocol. It's a proprietary and you're stuck with it. Or you can go non-specific with 20K ohm sensors. To be honest, you can change it in the field if the owner decided to change it in the future or had issues with the Silk Bus sensors. The nice thing about the Silk Bus sensors is they're relatively accurate. They are sort of foolproof. You install them and they work. So and they're required to be a certain level of accuracy, whereas maybe the 20K ohm sensor that might get replaced may not be. So there's sort of advantages and disadvantages to either route. Being on a commissioning side, I never like to see proprietary, but in this case, it might be something that owner may wish to have. My other concern with that is the Silk Bus sensors. These economizers as an assembly are going to last a lot longer than ones of years past, and so I have some concern that the Silk Bus sensor may not even be available when it does fail, and so I don't want them to have to replace an economizer because they can't get a sensor replacement. Other things to be concerned about, you will see Jade controllers on fan coils, and so the mixing box section is available. It still will be ultra low leakage. It will still have the actuator cycling and all the improvements that we discussed earlier. As you can see, the mixing box section on the right has gear-driven dampers. And so just issues I've run into are, where do they install the controller? It's been really frustrating at times because the Jade manual is really set up to install into a rooftop unit, and contractors just kind of, at least the ones that I've encountered, have been putting them kind of wherever they want and not necessarily the most accessible places or the most, in my opinion, logical places. And so that can be a concern. Next is weight. Definitely these units have significantly more weight than economizers of years past, even those with powered exhaust. Before, you definitely could get an economizer with powered exhaust less than 200 pounds. The units that I'm seeing now are coming in right around 200 pounds. A couple years ago, they were closer to 300 pounds. So there are improvements on that side of things, but just be cognizant of that. We do a lot of schoolwork, and if we're doing an HVAC replacement on a 5-ton unit, you might very well find yourself way over the structural design point for that unit 30 years ago, and so that may limit your ability to put on an economizer, or it just drives up the cost because you need to make structural improvements. Next are sort of just the limitations to understand when you're going about these units. One of the things I've run into is the powered exhaust. Most of these small rooftop units are manufactured by third parties. These economizers are manufactured by third parties, so you're not getting a Carrier economizer or a Train economizer, for example. You're getting CanFab or Micrometal or one of these more popular aftermarket products that these manufacturers approve, the RTU manufacturers approve. One of the frustrations that I've encountered is a lot of them will spec a 5-ton unit and a 5-ton exhaust fan for all of a given range of products. And so you'll see in the picture in the lower left, basically I've taken a snippet from one of the manufacturer's websites, and you'll see that the only option, this is a 3-ton unit, and the only option is 1850 CFM. By and large, a 3-ton unit is going to be 1200 CFM, and the max CFM on this unit is 1850 if I select that half horsepower exhaust fan. So what we often encounter is that you're so low in your exhaust that it doesn't start actuating, or it doesn't start engaging and flushing the building of pressure until it's quite a bit into its cycle. And so that can be an issue. Next thing is the Jade Economizer controller does not talk to a BAS, at least the ones that I've encountered so far. And the question there is, does it meet with the OPR? A lot of times I've seen, design engineers have become really accustomed to just saying, oh, I need a Jade Economizer controller. That's what I'm going to spec on the unit. Well, for some owners, if they have an existing EMS, that probably isn't going to be the solution they want to go down. And so there are other ways to meet that requirement. And really, at the end of the day, an EMS controller can do exactly what the Jade does and more. And so if the owner really wants that, that's something to flush out while you're helping them develop their OPR. Lastly, the Jade only accepts one CO2 sensor input. And so you just want to make sure that if you have, say you have a 7.5 or a 10-ton unit that's serving a couple conference rooms and they both need CO2, there are products out there that can help aggregate those two signals. And so this little device on the right-hand side is one of those examples. It basically takes up to 6 inputs, so 6 CO2 inputs in this case, and allows you to serve out the max, the min, or the average. Of course, for CO2, we would want the max. So, just little details that help you make sure that in the design process, everything's captured so that your owner isn't experiencing change orders down the line. One of the things that I've found some success with in terms of getting design engineers to specify are just the various set points and modes that the Jade needs to operate in. A lot of times, if the contractor isn't directed to do so, they just leave all the factory defaults, and that doesn't work. In most cases, it doesn't work. And so, I want the design engineer to tell in their design documents, I want them to specify, is it going to be enthalpy or is it dry bulb control? What is the cutout temperature? Because the default is 63, and for us in Southern California, 63 is way too low. We don't have nearly enough humidity for that to be the set point. Our lowest code required set point is 71. And then the enthalpy uses curves, so I'd reference you to the Jade manual for that. Also, what is the mixed air temperature set point? Default is 53. Maybe that works, maybe that doesn't, but the design engineers should think that through. And with our field experience, we can help them if they don't know. Demand control ventilation, this is always the argument. Can I get the minimum ventilation set point? They always have the max ventilation set point, but what's that minimum ventilation set point? Because otherwise tab's not going to know what to set it to. And then CO2 control point, is that 1,000 ppm, 600 ppm above ambient? Well, just specify it so that the contractor knows what they're looking for. And then if you're in a climate where you need to be concerned about it, just make sure that the low temperature lockout is specified. Next few things, exhaust fan control. Do you want it to be modulating, or do you want it to be, so building static pressure, or do you want the exhaust fan just to engage when there's a given damper position? The Jade can handle either. I always like modulating because it's responding to a building static sensor rather than some sort of relatively arbitrary damper position. The thing to know about the Jade is that it looks for, it holds out exhaust for a given minimum damper position, and I think the default is 30% open, and so that may or may not work. It's something to potentially commission in the field. It's sort of going to be site dependent, and so you want to make sure that the tab person is in fact looking for the right set point to engage the exhaust fan. Thermostat capability, this can be a really big issue. A lot of these units, if you're putting on this next-gen economizer, you're probably also going to look at potentially higher SEER units. So that could mean, multiple seat fans, cooling stages, and heating stages. Basic thermostats may not work. And so my perspective there, we do a fair amount of schoolwork, and a lot of the schools, they want their standard VentStar, the quote-unquote school stat. VentStar makes products that probably work, but it's not necessarily going to be the one that the school's already stocking. And so it's just a conversation to have with the owner, as well as to make sure that the design documents reflect what thermostat needs to make it onto the job. So now we'll dig a lot further into the Jades themselves. And so these are just the screens. We'll go through each and every one of them. Status. So if you're walking up to a Jade, you're going to see, the first screen you'll see is status. All the sensors are going to be there, whether the economizer is available and economizing, if it's actually economizing. The occupied signal, that can be a challenge, and we'll talk about that in a little bit. How many stages of cooling there are and whether or not they're enabled, the CO2 value, and then the fan speed. One cool thing about the Jade is that if a sensor isn't plugged in, they won't show up. So it won't show up in status, it won't show up in set points, and it won't show up in setup. And the nice thing about that is if you know that the CO2 is supposed to be on this particular project and you don't see any of those set points or statuses when you go up to the Jade, you know that either the sensor is not reporting or it's just not there at all. And so that obviously that can be a conversation with the contractor. In terms of CX portion of status points, one thing I'll sort of jump into is the sensors. The sensors have been a little bit of a challenge over the last couple of years because a few things. So the outside air is mounted in the outside air hood, and if the unit is off and you're reading it, it definitely conducts a lot of heat into that outside air sensor. What I would advise is get the unit running and wait about 5 minutes, and that outside air sensor should come down to the real outside air temperature. That's kind of true for any unit, but these aren't our sort of isolated north side of the building. While it shouldn't be in direct sunlight, and it won't be because it's in the hood, you are going to have to give it some time to get some airflow across it. The mixed air temperature sensor is not going to be in the mixed air temperature position. I think we all know that a mixed air temperature sensor should be upstream of the cooling coil and heating coil. In this case, in these small rooftop units, you really don't have a mixed air chamber, a mixed air plenum. And so the Jade manual will tell you to put it in that mixed air plenum. Well, that doesn't exist. So then you look at the manufacturer's documentation, and they'll have you put it downstream of the cooling coil, which we all know is a discharge air or supply air temperature. The manufacturer is right because I've tried to have them put it in find a spot in the mixed air, quote unquote, mixed air chamber. Really, you just end up reading either return air or outside air, and you don't get a good mixed air. So the picture at the right shows you the position on the fan. Basically, if you look to the left, you can kind of see the cooling coil, and then this is a downshot supply fan. So it is this is a gas-fired unit, so the cooling coil is on your left, and then it's pushing through the gas-fired furnace below it. So it's kind of in a discharge air position. For this unit, I would just highly recommend coordinating with the manufacturer and the documentation the manufacturer has for the Jade. Return air temperature sensor is optional. I've had a lot of good luck not having them, and I think for a lot of owners with these small rooftop units, they really just want sort of a dry bulb cutout or not comparing return air versus outside air. The simplicity of it has been the way my owners have wanted to go with the different projects, but obviously coordinate that during the OPR. Sensor configuration. Silk bus sensors come in two modes. You can buy, the contractor can purchase an outside air, a return air, and a mixed air sensor, and that's a specific part number, or they can order a generic sensor and flip dip switches. My advice to you when you get out to do sort of either your pre-functional checklist or just an initial site visit is just make sure that if it is the dip switch, that they've in fact switched it to the right dip switch position so that the sensor is reporting the the right position back to the controller. Occupied, as I said earlier, can be kind of a frustrating thing to get out of the thermostat. I've had a lot of challenges with sort of more basic stats in getting them to report the fact that they're occupied back to the Jade. This can cause all sorts of issues. More often than not, the Jade just will hold out the unit from doing almost anything. And so I'd advise you to read the thermostat documentation, make sure the contractor knows that this can be an issue and flushes it out long before you start functional testing. Otherwise, you could be, obviously the things we don't want, doing an additional site visit or waiting around while they program thermostats. The next thing I would say is that the CO2 value can come in as absolute or gauge. Depends on what CO2 sensor the contractor utilizes. So what I mean by that is either the CO2 sensor is going to report 400 ppm or it's going to report 0 ppm. I've looked through the Jade controller. I don't see any way to sort of account for this. And so the best method that I've come up with in terms of getting the contractor to make sure that the CO2 responds correctly is by just offsetting it. So if the CO2 sensor is reporting 0, then it needs to respond at 600 because it's not making up, it's already accounted for the ambient, and that is truly enabling demand control ventilation at 1,000 ppm. If it's reporting 400, which is the ambient condition, then it needs to actuate at 1,000 ppm or 600 above ambient, or whatever set point the design engineer specifies. Lastly, I would just recommend, what is cool when they do use silk bus sensors is that all the wiring comes labeled. So you're going to have the proper color, and so a mixed air temperature wire, for example, is going to have a specific color. I think in this case it's orange, and it will report. You can follow that back to the controller and follow it back to the sensor and make sure that everything's in alignment. You can do the same thing for the outside air temperature sensor, and so that can be really helpful in just making sure the sensors are wired properly. In terms of set points, there are a lot of set points to adjust on the Jade controller, just given the fact that how simple of a controller it is, there are a lot of adjustments. And so my best advice to you is go to the Honeywell demo website, and the picture at the right is a snippet from their flash-enabled demo screen, and you can literally click on the arrows and the enter button and go through just like you'd be sitting in front of a Jade, and just familiarize yourself with the controller. A lot of times with our functional testing, we're asking that the controls contractor to manipulate whatever to get a given response, right? Well, that's not going to be as simple for these cases because a lot of times with small rooftops, you may not have a controls contractor at all. And so that you're really going to be coordinating with a mechanical contractor who may not have the experience to, get around the controller quite as fluidly as a controls contractor would. Last thing on set points, if you go to the controller and you see that the dry bulb cutout temperature is still 63, you know very well that the contractor probably has not set up the job yet. especially if your design documents have already specified, what set point they should be at. That's a really good quick check to say, yeah, you guys still have some work to do. In regards to setup and advanced setup, I'd say control programming is very specific to a job because the unit's capability, the thermostat's capability, all need to be coordinated and they all come together in the setup of the Jade. And so my best advice here is hold a CX coordination meeting, help the mechanical contractor understand that this isn't just some simple device, and that if they have a controls expert on their staff, that should be the person who's setting up this controller, not necessarily the person who might be installing the unit. If they don't, then definitely talk them through what it's going to take and emphasize that this isn't a simple controller, and it's not just a thermostat. It's going to be there's going to be a numerous set points that they need help configuring. So the Jade checkout and alarms. A lot of contractors like to tell me checkout is commissioning or functional testing. It's not. It's really just, do the dampers fully open, fully closed? Do they go to the ventilation minimum position? They're not responding to a sensor input, so I don't call that functional testing. So just encourage them to still do all this, to still make sure that the damper strokes through its full stroke, and that all the stages of cooling enable and the exhaust fan enables, but that you're going to come through and do full commissioning, and you're going to need their assistance to configure any step points to make sure that that works. One word of caution, I will say that you can enable stage 1 and stage 2 cooling directly from the Jade, regardless of, it really depends on what safety features came from the rooftop manufacturer. And so just be cautious. If you're not running the supply fan, you probably shouldn't turn on the compressor. While it's not going to kill anything, you just don't want to do it. Make sure that if you're going to enable it, that it's in a state where it can be enabled. And also know that there's potentially, if the rooftop unit doesn't have its own internal safeties, you could enable the stage 1 and stage 2 cooling again and again and again, because you could potentially bypass the normal compressor lockouts of whatever it might be, 5 minutes. So just be cautious of that, especially if you're sending out a newer technician, newer commissioning technician. They just need to be cautious that this unit could be damaged, and they need to be aware of it. Alarms, there's some great alarms. If you unplug any sensor, any actuator, alarms will report to the alarm screen. So in checking that stuff, you can just pull off a mixed air temp sensor, and you should get an alarm. When you put it back on, the alarm should clear itself. So that's kind of nice feature of the Jade to just check that those exist. Actual commissioning, we already kind of talked about, just checking the sensors and going through all the various steps an economizer should go through. On the picture on the right, that's the outside air temperature position recommended by the manufacturer. As you can see, it's bolted directly to a piece of sheet metal, and it's hard to tell, but the filter, the sort of outside air bird screen, is right below it. That unit does get a lot of radiant heat from the sun on a bright sunny day, and so that sensor will read very high for the first 5 minutes of no airflow. But once the unit starts, it generally comes down to a temperature that's reasonable. When you're writing your functional test, I'll say that the Jade manual is excellent. No matter what configuration your unit might have, say it be 2 stages of heating and 1 stage of cooling and 2 stages of fan, or whatever the case may be, the Jade has, you can see the picture in the lower portion of the screen. That is a snippet from the Jade manual, and for this example, it's does it have DCV? Yes or no? Is it good to economize? And you can just go follow it across the right, and that is what you should expect to see the system performing at for a given sensor input. And so that can be really helpful in just understanding all the things you should be looking for to confirm the unit's operating properly, and then also just helps write your functional test. It's not going to be all inclusive, but it's going to be pretty close. Again, set points are very easy to override. Obviously, you'd want the mechanical contractor to be overriding them because they're ultimately responsible for the piece of equipment. The one thing I'll say is if you live in a hot climate like I do, the dry bulb cutout temperature limit is 80 degrees. Don't make the mistake like I did and show up on an 85-degree day thinking you can override the controller and quickly test the economizer. That will not work. So just be cognizant of that. Thermostat settings and configuration critical. Like I said before, just make sure that the contractor understands all of those components need to work. They need to test it before you arrive. And I hate to say this, but I still have yet to find a Jade thermostat and rooftop unit all as one package, be completely set up right. Even when it's been, I've done 3 jobs with the same contractor. There seems to be little nuances in every one, whether it be a 2-stage fan or 3 stages of cooling, whatever the case may be. Something seems to be a little bit off on each one. Excuse me. So, lastly, I'll just say bring data loggers. The getting all the modes to enable can be challenging. I've run into internal lockouts on the rooftop units, issues with the thermostats, et cetera. It's just, you may be better off leaving a couple sensors in the units to get your values and doing some trend analysis, pretty much like any other job, but just be cognizant of that. There is no trend capability in the Jade, so if you want that trend data, you're going to need to get it yourself. Some lessons learned, this first page, to some degree we've gone over, but we'll just retouch real quickly. Again, just go over the RTU manufacturers. They're all going to be different. Just make sure that where the RTU manufacturer says to install the sensor is where it's actually installed. The Jade can't account for every RTU, and so the Jade, Honeywell can't account for every RTU, so that specific manufacturer of the RTU is really where you want to go to make sure the mixed air sensor is installed correctly, or what often becomes the discharge air temperature sensor. CO2 sensor, like we talked about before, is it gauge or is it absolute? And then many contractors leave the factory default. That's just standard. You just try and coordinate that as much as possible. And then the dip switch configuration. All those we covered before. These ones we haven't, and so these can be challenging as well. The vent minimum on small units can be so low in some cases that the tab can't get a good reading at an outside air damper position that you might walk up to the unit and think is normal. So the actuators on these units are going to be 2 to 10 volts. So 2 volts is closed and 10 volts is open. And what I've found on a lot of them are that really low airflows just don't trigger. And so you're up at 25% open damper before you get any airflow. And so when you might be looking for, say in a 3-ton unit, it's obviously 1200 CFM, and maybe you're looking for a vent minimum of only 120 CFM, roughly 10%. The damper it's just, you're not getting any airflow at 10% open. Obviously, dampers aren't linear in terms of airflow, but what I found is that the return path continues to be the easiest path for air to flow, and so you don't really get actuation. What I have found is that you get no airflow at, say 20% open, but at 25%, a lot of times you're going to be above what the design minimum is. And so really, you got to make the decision whether you want no airflow, which of course isn't code compliant, or do you want to have a little bit more than the design ventilation minimum. Obviously, it's a tab report. It's going to go back to the engineer for review, but you can do your part in helping the design engineer understand why that condition is there and confirming that you did witness that being an issue and that the tab contractor did make the effort to go and get it as low as possible. Another issue I've run into is the controller not allowing DX cooling at 100% economizer. So if it is, say 68 degrees outside and the return air temperature is still, say 74, we should still be an economizer. But the economizer damper is 100% open. We still might need a little bit of DX cooling because maybe we're looking for a design discharge air temperature of 55. And so a lot of the units I've found with the Jade that happened to be single-stage cooling, at least 3 jobs in the last 2 years. They've had to call Honeywell and coordinate a solution, get approval to, ultimately what came down to was jumpering the controller. And so I just recommend that if you have a single stage unit, be cognizant of that. Definitely test the fact that DX cooling does come on when you have 100% open damper, and just make sure that all phases of the economizer cycle are functioning properly. I'm sure that Honeywell is going to work that bug out or help the configuration of the setup so that it's not an issue in the future, but I'm still running into some units that have it. I'm not entirely sure whether it's a bug or whether it's just the contractor configuration, but it is continuing to occur. As we talked about, thermostats just play a huge role. Definitely make sure that every portion of the thermostat, whether it be single-stage cooling, 2-stage fan, 2-stage DX, whatever that case may be, just make sure that all of your thermostat settings actually function so that your owner doesn't have any issues down the line. And then, before you go out to the site, I'd highly recommend you read the Jade manual as well as go through that demo tool I recommended. If you just type in Jade demo Honeywell, you'll get that flash-enabled website. So definitely have your technicians who are out in the field go through that before going out to the site. That wraps this up, and thank you so much for giving me the time, and I guess we'll take some questions now.
Great, Brian. You have, let's see, one question here. It was early on in your presentation, and the question is, are these gear dampers all opposed blade action, or do they provide parallel blade action? The person asking the question says parallel blade action is best for lowest fan energy penalty and linear mix in the plenum. What do you think of that?
Okay, I think there's a couple questions in there. So are they opposed or are they parallel?
Yep.
They are opposed. I'm almost positive they're opposed. I'd have to double check, but I'm almost positive they're opposed.
And do they provide the parallel blade action as well, or do you think it's all opposed?
Everything I have seen, the gears are turning opposite outside air to return here. So I don't see a way. I guess the short answer is I'm not sure. I could definitely follow up and get that person an answer.
Okay, so because they felt like the parallel blade action is best for the lowest fan energy penalty and linear mixing in the plenum. And do you agree, or what do you think about that statement? Do you have an opinion?
There isn't, if we look at, I don't know if they probably can still see my screen. I went back to that picture of the unit, and so at the picture on the right, there's the outside air is on the top, of course, and the return air is going to come up from below and go across the cooling coil. There isn't a great amount of mixing that occurs before the cooling coil, and so I'm not sure in these small rooftop units that it really matters. That's probably up for discussion.
Perfect. And I think that's the only other question we had today. Oh, no, sorry, one more in. Are these controls exclusive to Honeywell units, or will you see these controls as custom applications on other manufacturer units? Do you know the answer to that?
The economizers that I've seen on these small rooftops are going to be manufactured by Micrometal or Canfab, and they use the Honeywell product at their option. A lot of times, there's one other economizer manufacturer, but I can't remember off the top of my head. But they have the option of using the Belimo or the Jade. In California, they have to use an approved controller that meets certain requirements. Whether that includes fault detection and a number of other things. But Yeah, so the manufacturer of the Economizer is who's generally picking whether they use a Jade or not. I will say that, like, once you get up to 7.5 to 10 tons, sometimes you'll see the Jade, or sometimes you'll see the manufacturer's controller. So I know I see a lot of carrier units, and some jobs will have the Jade, and some projects will use carrier's RTU open controller that also meets the control requirements. So.
Okay, perfect. Well, that's it for questions for today on this one. Brian, I want to thank you for taking the time, and the California chapter for making this happen today. Do you know these Tech Talks are on the third Monday of every month? Each chapter has agreed to take on a month to help deliver these Tech Talks as a member benefit. Next month, I believe it is the Southeast chapter, and we'll look forward to that. We'll get you information out on that. This one has been recorded and will be up on the website shortly. Again, the passcode for all Tech Talks is Tech Talks 2017. This is a member-only benefit, and we hope you enjoyed today's one and look forward to next month's. It will be on February 19th. Thanks all. Have a great day.